Okay, here we're going to do a rate, distance, time problem. And what we have is a train that's going westbound, like this, and then another train that's going eastbound, like that. And the one that's traveling westbound says it's 20 miles per hour faster. So we're going to faster is plus 20, but faster than what? Well, it's faster than the rate of the eastbound train. So we're going to let the rate of the eastbound train, so that's R with a subscript E, be X, and that means the westbound train is X plus 20. So this is the rate of the westbound train. Now we're just going to kind of do these in columns with rate, distance, and time. So then the next fact that it gives us is that the distances between the two is 510. So that tells us that the distance of the west plus the distance of the east is going to be 510 miles apart. And then it says that they were 510 miles apart after 3 hours, which means that the time for the west was 3 hours and the time for the east was 3 hours. Now, I need to find out what is the rate of the westbound train. So after I create an equation, solve for x, I have to add 20 because that is over here on the left. Now, let's see, what can I get from this? I still need to figure out what form of the equation that I need to use. So the relationship between rate, distance, and time, I always think I'm in my car and my speed is my miles per hour. So miles is a distance, hour is time. So my formula is rate equals distance over time. And then I can rearrange that by multiplying by t, and if I need to, divide by r, so whatever I need. Now, let's see. I know that if I can come up with an algebraic expression for the distance of the westbound and the distance of the eastbound, then I could use that equation. So I want to solve this for t so that I've got distance equals rate times time. So the reason I knew to do that is because I could see what equation I needed because I read the problem. Whatever they give you the total of, sometimes they give you the total time. Sometimes they say, that when are they, who knows. Well, anyway, this is this problem, so let's stick with that. So the rate times time of the westbound train, rate times time, well, I'm actually going to do it as time times the rate, and then I'm going to add that to the distance of the eastbound train, and that's going to be its rate times time, which is just 3x, is equal to 510. So let's see, what can we do here? Okay, we're going to distribute the 3. We get 3x plus 60 plus 3x equals 510. I'm going to add those x's up, and then we're going to subtract the 60 from both sides. That's a 60. It's kind of hard to write with this little stylus. And I have 6x equals 450. And then I'm going to divide by 6, and I have x equals 75 miles per hour, right? But what was that? That was a bad P. We need to go back up here and look. So x, see right here, x was the rate of the eastbound train, and what they wanted me to find is what is the rate of the westbound train. So that's my last step there, is the rate of the westbound train is the x plus 20. So let's move that back up. And we write rate of the westbound is 20 plus 75, which is 95 miles per hour. Okay, so I'm going to talk just for a minute about how we come up with the equations. So looking back at the original, looking back at the original, what do we have here? See that the item that they give you that's critical is sort of this step right there, 510 miles per hour. That helped me build the equation. And then I had to play with formulas to see how to, write that and that as algebraic expressions. So other problems would give you other totals. Sometimes they say things like, oh, I can't, yeah, I'm not being helpful now. Let me just hit save on this one.